In this video, we are going to start our study of non-right triangles. Up to this point, we've worked with nothing but right triangles. If it's not a right triangle, it's called an oblique triangle. You might have heard of the word scalene too. That's a different word for it. All right, so we're going to work on solving these, meaning if I give you two angles and a side, or some sides and an angle, can you find all sides, all angles? Now, we have three cases that we're going to mainly deal with. We're going to either have this angle, side, angle. So notice that's angle, side, angle in order. So that the side is in between the two angles. I also have angle, angle, side. So angle, angle, side. These two scenarios, if I'm given two angles and a side, or and with the side outside of it or the side in between them, I actually can solve the triangle really easily. No problem. There's one triangle. I'm going to solve for it. Now, if we run across this, and all curriculums like to flip it, but I'm going to go ahead because it's easier to remember if we see this. Maybe because I'm 12 years old, but I know that if I see that, if I have angle side side, then I potentially have a problem. So there is a potential problem. The problem will be, and I'll put it in here, 1, 2. It'll be 0, 1, 2, forgive me. 0, 1, 2 triangles. You're either going to have 0 triangles, 1 triangle, or 2 triangles. And we'll see how this works out as we go forward. But if you can catch that, then you'll know to be aware. All right, so how do we get there? How do I solve a non-right triangle? All right, so here's a non-right triangle. They took the big triangle here. This was the original triangle, and they just put it on its side and dropped a perpendicular. So they have this perpendicular drop there with that height. So now we did create two right triangles. I have this one, and then I also have this one. Two right triangles. Good enough. All right, so we can set up two ratios then. This is angle alpha. So sine of alpha is equal to, okay, sine is opposite over hypotenuse, which is going to be b. If I solve this equation for h, I just multiply both sides by b. Can also do it for the right triangle. This is dealing with beta instead of alpha. Sine of beta is equal to h opposite over a, the hypotenuse. So that means h is equal to a times sine beta. Well, if they're both equal to each other, that means I can set them equal. So we get b times sine alpha equals a times sine beta. To make it a little prettier, I'm going to divide both sides by ab. So you can see on the left side, I'm just going to get left with sine alpha over a, and then sine beta over b. I could have flipped the triangle over. A and b were kind of arbitrary. So that we get a third equation here, sine of gamma. So here's our three ratios, two ratios. I don't know how you'd want to define that. Um, I guess three. There's three fractions. I think I was doing equals. Anyways, law of sines is right here. We're only ever going to use two at a time. You'll never use all three, but you could use these. This is equal to that. I could do that is equal to that, or I could do this is equal to that. But I'm only ever going to use two at a time. You could also flip each one of these. So if you forget which way it goes, you'll be safe. I don't see much people use the highlighted one there. They mainly use the one on top, but it genuinely doesn't matter. All right, so let's do an example. I'm going to label everything. Okay, I got an alpha, I got a beta, and a gamma. I like to do this. I would recommend it because the next two sections will be setting this up, and seeing the way it sits here in this chart will tell you what to do. That's my hope. So alpha is 50 degrees, little a is 10, beta or gamma is 30 degrees. 50 and 30 make an 80. Triangles still, even if they're not right, add to 180. It only changes if we change the world we're in. For instance, if you were to do a triangle on the surface of a globe, the angles potentially could add up to 270. Other geometries exist. So I can go on a whole rant. Right now, our universe is potentially hyperbolic, which means our whole existence is on something like the inside of a globe. But again, everything, these are theories. These are my YouTube rabbit holes. If you're ever curious, I want to talk about it. Okay, so I have these. I'm missing this. and that, right? So this actually tells me when I have this in one measurement, either there, it could have been here or here, either way. But when it's set up like this, it tells me to use law of sines. So I'm gonna go ahead and set it up, leave some room because we're going to have to do it twice. So I'm gonna do sine of alpha over A is equal to sine of, let's just go ahead and do beta over B. Okay, so I'm gonna plug everything in. Sine of 50 degrees over 10 equals sine of 100 degrees over B. So the reason it worked when I have that is notice once I plugged everything in, the only variable is B. All right, so I am going to, like we did a second ago, cross multiply both sides. All right, I said a second ago, but I'm referring to another video. 50 degrees, and then 10 times sine of 100. I don't plug any of this in until I get to the last step. So I'm going to divide both sides by sine 50. So that's 10 times sine of 100 degrees over sine 50 degrees. Make sure your calculator is in degrees. All right, so we're going to do 10 sine 100. I like to push enter and then divide so I don't mess it up. Sine over 50. I know my calculator's in degrees because I just used it. So, but you should definitely double check. So this is roughly about 12.9. All right, so B is 12.9. Now, it's very tempting here. You guys are so used to when you solve triangles, we've been dealing with nothing but right triangles. The Pythagorean theorem only works for a right triangle, so I cannot use it here to find C. I can only use the law of sine. So I'm going to set it up again. I'm going to use sine alpha because they gave me every part of that. I don't want to use beta because B is something I came up with. I want to make sure it's right going after this last one. And then sine of gamma now over C. All right, so let's plug them in. Sine of 50 degrees over 10. See, that's the reason I'm using it is because 50 and 10 were given to me. I know those aren't wrong. So there's a chance I could get this right. Sine 30 degrees, even if all that is wrong. Over C. So notice C is the only variable. So I'm going to jump a step forward here. I hope you'll be okay with it. But I would times 10 by sine 30 if I cross multiply 30 degrees. The sine 50 would be with the C, which means I'm going to divide. So this is roughly, all right, 10 sine 30. I knew that one. Divided by sine of 50, which is roughly about 6.5. So we have solved the triangle because we have found all sides and all angles. All right, so the big mistake I see here is I do recommend always going back and using things they gave you, not the thing that you came up with, just in case it's wrong. And then the mistake I see here often is people don't do it twice. They end up doing the Pythagorean theorem, which is invalid here because it's not a right triangle. All right, let's do one more where it works out pretty nicely, and then we'll get into the messy part of this section. All right, so again, I like to write them. Alpha, beta, gamma. A, B, C. All right, so alpha is 98 degrees. Little a we don't have. We have gamma, 43 degrees. And then 22 is across from beta, so it's right here. All right, now you may be looking here, and in the last example, I was like, oh, you got to have two of them and then one other measurement. But notice we only have one measurement of each. But what we can do is figure out that beta, because triangles still add to 180, no matter if they're right or oblique. So I'm going to do 180 minus 98 minus 43. So we get 39 degrees. So now for sure, I can use law of sines because I have two and then one measurement of another. So we'll do that. All right, so this is going to be, I'm going to write down the rule, sine of beta over B, and let's go ahead and go after A. Sine of alpha over A. Let's go and plug those in. So sine of 39 degrees over 22 is equal to sine of 98 degrees over little a. You'll get used to these where you'll jump from that to this pretty quick because you could see the cross multiplication. Okay, I'm going to multiply 22 by sine 98 degrees. If you can't see it, go ahead and cross multiply and solve. No big deal. I've just done a bunch. And then times by a and divide by sine of 39 degrees. All right, so we get 22 sine 98 divided by sine of 39. So we got roughly about a 34.6. Now, I usually go up here and just make sure, it's kind of hard to tell sometimes, but this makes sense with the other number given. If I have a triangle, one side is 34, the other side has to be a close to there if these are all rational. If I had an angle that was like 0.004, then maybe this could be, 1000. But if all the angles are about the same size, then I also know that the sides are going to be that. Also, one thing to point out is they go together. Like 39 degrees is 22. If the angle is bigger than the angle, like this is bigger than that, then this side has to be bigger than the corresponding side. So if we would have solved for A and got a 17, we did something wrong. All right, so we got to do one more for C. We can't use the Pythagorean theorem. So sine of gamma over C. And let's go ahead, what was given? Beta. Sine of beta over B. And we plug it in. So we get sine of 43 degrees over C. And then we get sine of 39 degrees over 22. So we get 22 times sine of 43 degrees equals C times sine. I don't know why this one I decided to do, but here we are. And then I divide both sides, so I get C is equal to 22 sine 43 degrees. And then that's over sine of 39 degrees. And then that's going to give us a number. All right, so let's plug that in. So 22 sine 43 divided by sine 39. So I got 23.8. Now, this should make sense with the angles as well, that if this is 23.8, that means this 43 is slightly bigger than that. Yeah, that checks out. So there's our answer. We have solved the oblique triangle. So these take a little more time than the right triangle, especially when we are given the ASS scenario, but I will work out that whole thing in the next video. It will definitely take some effort. The next section, we're leading into the law of cosines, and then we're going to take a pretty hard right turn into like 5 topics at the end of trigonometry that aren't this involved. The last chapter of this unit is what's going to actually make our final not so bad because the work is not that involved. All right.